Hey guys, this is Souradip Sarkar, your mathematics mentor. You are watching right now Canvas for JEE YouTube channel. So today in this video, this is the lecture number 3 of the method of derivation, and let's start this video. And I think these videos will be very much essential and important for you. Implicit function and the derivatives of identity using differentiation and standard substitution methods over there. Okay, let's go without wasting our time. Let's go for the questions, and theories over here. We have to practice lots of questions for these competitive exams, as they mention advance or any other states competitive exam, like. Okay, so let's start today's lecture with the derivatives of implicit function. First of all, what is implicit function? You have seen the functions like y equals to x square plus 5 sine cube x plus 3. These are the ordinary functions. Okay, but the implicit function is that in which function y not equals to of fx, as y is always included in that functions. Okay, let's see some examples over here. What is implicit function? We are changing the color, that is examples of implicit function. That is, you can rather say that number one, that is x square plus 2xy plus y cube equals to 4. This is an implicit function. We can't take y as identical function, or okay, so and then another example, that y plus x plus y plus sine of xy equals to 11. Okay, and this is over here, that is where y not equals to fx. We can't differentiate with y and x as a function of this. Okay, so in these questions we have to solve this at the point. Okay, let's first solve a question as which is that if x square plus 2xy plus y cube equals to 4, which is the example number 1, then find dy dx. Okay, first of all, you have to take the derivatives over here, that is ddx. We have to write down the equation, equation x square plus 2xy plus y cube equals to 4. Then we are going to take the derivatives over both the side, that is derivative of x square will be 2x, derivatives of x and y, it will be x y dashed plus y x dashed plus y cube. We can write it over here, that is 3y square into y dashed equals to 0. This is the style and the pattern of the questions. Okay, so here you can write, from here you can write that y dash will be equals to minus of 2x plus 2y divided by 2x plus 3y square, or rather you can write y dash as dy dx. This is equals to same, minus of 2x plus 2y divided by 2x plus 3y square. Okay, okay, this is the answer of this question, dy dx we have to find. Okay, so next to go to the second question, that is if y power 5 plus x y square plus x cube equals to 4x plus 3, then find dy dx at the point of 2 comma 1. Okay, let's see. We have the functions, that is y bar 5 plus xy square plus x cube equals to 4x plus 3. We have to take the derivative in the both side, that is 5y power 4 into y dashed, that is dy dx, plus x into y square, that is x 2y dot y dash plus y square into 1 y square into 1 plus 3x square equals to 4 plus 0. This is the answer. Okay, I am changing the color. This is the answer of the question. Okay, let's see about that 5y power 4. We can write y dash as dy dx over here plus 2xy dy dx plus y square. I am taking off the brackets plus 3x square minus 4 equals to 0. So in this side we have to take dy dx common, as so we can write 5y power 4 plus 5y power 4 plus 2xy equals to 4 minus y square minus 3x square. So the value of dy dx equals to 4 minus y square minus 3x square divided by 5y power 4 plus 2xy. Okay, have a look over here and you will understand the questions. Okay, so now we have to find dy dx at the point of 2 comma 1 as x equals to 2 y equals to 1, x comma y we can write. Okay, so the value the value of y is 1 square minus the value of x is 2, that is 2 square, that is 4 into 3, that is equals to minus 12. Okay, after that 5y power 4 is 1 as it is 5 plus 2 into x is 2, y is 1, that is we can write here 4 minus 1 minus 12 divided by 5 plus 4. Okay, so it will be 4 5 minus 12 7 4 13 minus 4, that is 9, and 5 plus 4, that is also 9. So minus 9 divided by 9 equals to minus 1. This is the answer of the question. Okay. Have a time and look the solution of the question, and I think you should understand the whole part over here. Okay, let's go for the next question. Yeah, let's go. If this question said that if y equals to root under sin x plus root under sin x plus root under sin x plus dot 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 up to infinity, then find dy dx. Okay, changing the color of the question. Okay, so I think you have seen these types of question earlier, as this is the exponential question. Okay, so here you can see that I am changing the color, that is y equals to root under sin x plus root under sin x plus root under sin x plus root under sin x. It will be going to the infinity. Okay, as it is going to the infinity, so we can write also this part, focusing on this part, that we can write this part also as y, as this also the function of x, this also the function, that is y. So yeah, we can write over here. So the solution of the question will be y equals to root under sin x plus y. Okay, so we have to squaring the both side, y square equals to sin x plus y. Then we have to take the derivatives of in the both side, y square derivative, that is 2y dy dx equals to sin x derivative, that is cos x plus, and this will be also dy dx. So we can write dy dx equals to cos x divided by 2y minus 1. This is the answer of the question. Sorry, this is the answer of the question. I think you have understood this question. Okay, I think you should understand these types of question. This will comes in JEE Mains and advance also, this type of question, and you have to take a practice over there. Okay, and let's go for the next topic over this today's lecture, that is standard substitution. So let's start. What is standard substitution? If we have a function, we can substitute the function of x so in our convenient way, so that the solution will be much more easier. Okay, let's see the expression. These are the expression, that is root under a square plus x square. If we put x equals to a tan theta and x equals to a cos theta, we can put both types. Okay, we can put any types of the question. Sorry, this is a major mistake, that is this will be a cot theta. Okay, I am writing down, that is this will be a cot theta. Okay, this will be a cot theta. And also for this expression, root under a square minus x square, we can write x equals to a sin theta or x equals to a cos theta. Okay, and for these types of function, that is root under x square minus a square, we can write x equals to a sec theta, and x equals to a cosec theta we can write. And for these types of function, okay, these types of function, we can write a plus x by a minus x, or a minus x by a plus x, we can write x equals to a tan theta. Okay, we can write over here. Okay, let's go for the next question. Also this is also true over here, and let's go for the questions solving. Okay, your first question is question number 1. Find dy dx for y equals to tan inverse 1 minus cos x by sin x. Okay, where minus pi, x lies between minus pi to pi. Okay, x lies between minus pi to pi. So now the question is, we have to take y equals to, okay, I am changing the color. We have to take that y equals to tan inverse one minus cos x by sin x. See, 1 minus cos x by sin x, we can write, if we think that we can write 1 minus cos x as 2 sin square x by 2. Think over that. 2 sin square x by 2. 1 minus cos x equals to 2 sin square x by 2. I think you should get 2. I can write here, that is 2 sin square x by 2. And sin x, we can write sin x equals to 2 sin x by 2 cos x by 2. We can write, I think you should understand this, 2 sin x by 2 cos x by 2. We can write it here. Okay, so here 2 and 2 cancel out. Sorry, I'm changing the color. Yeah, here 2 and 2 cancel out, and sin x and 1 sin x by 2 will be cancel out, and it will remains as sin x by 2 divided by cos x by 2, which we can write as tan inverse tan of x by 2. So we can write over here, that is x by 2. So y equals to x by 2, dy dx equals to half. This is the answer of the question. Very simple ones. Okay, let's go for the next part. Next question, question number 2. This is said that y equals to tan inverse root under 1 plus x square minus 1 divided by x in so find dy dx at the point of x equals to 1. This is the question. Option I am writing down the options. That is option A equals to 1 by 2, option B equals to root 3 by 2, option C equals to 1, option D equals to option D equals to 1 by 4. Okay, pause the video and try to solve this question in your own copy, and after solving the question come in the solution. Okay, let's start. First of all, you have to assume some functions which can substitute the value of x, so it will be similar and easier for you. Okay, so in this scenario we are taking that we are assuming, sorry, this color is not visible over there. Okay. We are assuming x equals to tan theta. We are assuming x equals to tan theta. Then we are putting the value of that is y equals to tan inverse. So if we put root under 1 plus x square, the value of x will be tan theta, that is it is gone. It is 1 plus x square. Okay. So root under 1 plus x square, we can write x equals to tan theta, so it will be sec theta. It will be sec theta minus 1 divided by tan theta as it is. So sec theta minus 1, we can write it over here, that is it is as similar as that is equals to tan inverse 1 minus cos theta divided by sin theta. So over that, in the previous question you have seen the same scenario over there, 1 minus cos theta divided by sin theta. I am not doing the same silly thing over here. So I am taking the value of tan theta by 2, so it will be theta by 2. So we can write the value of y equals to theta divided by 2. This is our first part completed over this question. Okay, so now the main question is, we have taken that tan x equals to tan theta. So in this case y comes as theta by 2. So we can write it here. I am changing the color just once. That is y equals to half of tan inverse x. We can write it. Yeah, we can write it. Then dy dx at the point, and first of all we have to find the dy dx, that is half into 1 by 1 plus x square, and then after that dy dx at the point of x equals to 1, it will be 1 by 2 into 1 by 1 plus 1, that is 1 by 4. This is the answer of the question, that is option number D. This is the answer of the question. Okay, let's go for the next part of our today's discussion. That is I guess you have understood these questions and derivatives of the following an assumption of the question. Okay, and let's go for our next part, that is special form. It is mainly that differentiation of one function, one function with respect to WRT other. Okay, let's see what it is saying. That it is saying we have to find, first of all we have to find the dy dx, and after that we have to take d of fx divided by d of gx. So here we can write it over here, that is d of fx dx we can write, and divided by d of gx by dx we can write. So it will be f dashed x and also g dashed x. So the one is a short example, that is ln x with respect to sin x. Okay, this will be eventually like, it looks like 1 by x divided by cos x. You can think 1 by x divided by cos x, as derivative of ln x equals to 1 by x and derivative of sin x equals to cos x. We have take this part over here, f dash x divided by g dash x. Okay, this is the answer of the question. And let's go for the next question, that is question number 1 in this section. Differentiate log sin x with respect to root under cos x. Okay, so we have to take first of all we have to take log of sin x, derivative of log of sin x. I am changing the color. Okay, let's see this color. Okay, derivative of log of sin x, it will be 1 by sin x into derivative of sin x, it will be cos x, divided by root under cos x, it will be 1 by 2 root cos x into minus sin x. Derivative of root under x, it will be 1 by 2 root x. So we have write over here 1 by 2 root cos x, and derivative of cos x equals to minus sin x. This is the answer of the question. Okay, okay, this is the answer of the question. And so our next and final question of today is that if this question is belongs from the common area of derivatives. Okay, all concept will included in this, that is if y equals to sine of sin x, y equals to sine of sin x, then prove that p dot t, that y2 plus tan x into y1 plus y cos square x equals to 0. So here this is the question. Okay, so first of all I am clearing you that changing the color, y2 is y double dashed and y1 is y dashed. Okay, so first of all we have to take the derivative of y1. So what will be y1? Y1 always should be, we have change the color. Okay, we have y equals to sine of sin x, we have it. So y1, that is y dashed x, it will be cos of sin x into cos x. Then what will be y2? Y2 will be cos of sin x into minus sin x plus cos square plus cos x whole square into minus sine of sin x. Okay, this is the answer. We have take y1 and y2. After simplifying it to y2, we can get y1. See, y1 have cos of sin x and y2 also have cos of sin x into cos x. Okay, so we can write cos of sin x over here, that we can write cos of sin x as y1 divided by cos x into minus sin x and plus cos square x into minus sine of sin x. It is as it is minus of y. Okay, this is this is it. After that we have simplified it. After that we can write y2 equals to y1 divided by y1 into minus of sin x divided by cos x, that is minus of tan x, plus cos square x into y, cos square x into y. Okay, so we can write it over here, that is cos square x into minus y, it is minus y. So we can write it over here, y2 plus tan x into y minus y into cos square x. Sorry, this is minus, not this is plus, equals to 0. This is the answer of the question and we have proved. Okay, so this is it. It is our last question of derivatives. Okay, and the method of differentiation, or you can say the method of derivatives, has completed over here, and it have completed in 3 lectures. Okay, after that you will get the integration as a definite integration and indefinite integration are the in 3 parts. Okay, so this is it. It is ended over here, and thanks for watching this video. Share this video with your friends so that they can access over these free contents on YouTube and have solved these types of question. It will help you to have a better percentile in JEE Mains. Okay, it will help you having a better percentile in JEE Mains. So this is it up to this, and thanks for watching this video. So subscribe our channel and hit the bell icon for further notification, and we will come with definite integration and indefinite integration with the next part of our videos. Okay, till then stay tuned and keep learning and keep exploring. Bye bye.